asymptote is a line that a curve approaches as it heads towards infinity, but it never crosses. This is what we're going to work with when it comes to rational functions. There are three types of asymptotes. There are horizontal asymptotes, so that's when I approach a line of the form y equals a constant. There are vertical asymptotes. That's when I approach a graph of the form x equals a constant. And there are oblique asymptotes. Those are going to be equations for lines of the form y equals mx plus b. So there are quite a few rules on how to find these different asymptotes. One of the most familiar rational functions is the reciprocal function. This is y equals 1 over x. It has a vertical asymptote at x equals 0 because, as you can see, y equals 1 over x. So if I divide my denominator equal to 0, my domain is all real numbers except 0. It has a horizontal asymptote at y equals 0 because if 1 is my numerator, right, and that number is never going to equal 0 because I'm always dividing it by different x values, and there's no way 1 divided by something could give you nothing. So it's never going to cross the line y equals 0. So we've got two asymptotes here. Another very common rational function is, this is the reciprocal squaring function. It also has a vertical asymptote at x equals 0 because its domain is all real numbers except 0. And as you can see, its range of possible y values, y could never equal 0 because you can't take 1 and divide it by something and get 0. So its range is all y except where y equals 0. That's also the range for the reciprocal function. So let's go over the rules of how to determine asymptotes. So 1, vertical asymptotes. You find vertical asymptotes by setting the denominator equal to 0 and solving for x. If a is a 0 of the denominator, i.e. it's excluded from our domain, the line x equals a is going to be a vertical asymptote. Next, I will have a horizontal asymptote if the numerator has a lesser degree than the denominator. So for example, if my numerator was x squared and my denominator was x cubed, this would have a horizontal asymptote because my numerator has a lesser degree than my denominator. So this has a horizontal asymptote at y equals 0. This also has a vertical asymptote because it's x cubed. And the cube of x is 0. Okay. Note, for other asymptotes, you can't have all three. You have one or the other, not all three. So, if a numerator and a denominator have the same degree, and the function is of the form f of x equals a n x to the n over b n x to the n, there's a horizontal asymptote at a n over b n. So let's just look at f of x equals 3x over 4x. Because they have the same degree, I have a horizontal asymptote at y equals 3 over 4. So y equals 3/4 would give us a horizontal asymptote. The last type of asymptote is a very special type of asymptote, and it's called an oblique or slanted asymptote because its equation is a line. So if the numerator is of degree exactly 1 more than the denominator, then there will be an oblique asymptote. To find it, you have to divide the numerator by the denominator and disregard the remainder. And then you set the rest of the quotient equal y to obtain the equation of the asymptote. So let's go through an example of this. So let's come up with an example for oblique asymptote. If I have f of x equals x squared minus 5x plus 6 over x plus 2, I'm going to go ahead and divide this. I'm going to do long division instead of synthetic just for the practice. So I've got x squared minus 5x plus 6 times x plus 2. And I say, okay, what do I multiply x by to make it look like x squared? The answer is x. So x times x is x squared. X times 2 is 2x. I subtract this. That gives me negative 7x plus 6. Well, what do I multiply x by to make it look like negative 7x? The answer is negative 7. Negative 7 times x gives me negative 7x. Negative 7 times 2 gives me negative 14. I subtract this. 6 plus 14 is 20. That's my remainder, but I can just ignore that. I have an oblique asymptote at x minus 7, at y equals x minus 7. That's a line with positive slope and y-intercept of negative 7.